Okay, so we're going to talk about a few things with electromagnetism that are pretty awesome. We're going to make something light, talk about Faraday's law, look at some motors and generators, microphones and speakers super quick, talk about antennas and radios, and that's going to kick us off into electromagnetic waves. And then we'll talk activity 2, which is basically just 2 videos in another 3-2-1 form. Okay, here we go. On to the first simulation. We have a magnet. Ta-da! Magnetic fields around it. So when I move the magnetic field changes. We see the little compasses changing. But we can also do that with an electromagnet. Basically just a coil of wire that also behaves like a magnet. Because if you have a moving current, that generates a magnetic field. Why, you ask? There's some special relativity going on in there, and there's a cool video about it from Veritasium in last week's electromagnetism playlist if you want to check that out. But suffice it to say, if you have moving charges, you have a magnetic field. One creates the other. Okay, cool, so that behaves like a magnet. Nice part is we can turn it on, turn it off, flip the direction, do cool things with it. Great party trick, Mr. J. Who cares? Well, you care because we're all using electricity right now. How do we generate that electricity? We take a magnetic field, and if we can change the magnetic field, actually let's do this one first. If we can change the magnetic field around a coil of wire, guess what? A changing electric field, so current, creates a magnetic field, but a changing magnetic field also creates a current. It works both ways. They work backwards. So if we can change the magnetic field around a coil of wire, that's going to get electrons moving. If we have electrons moving, that's going to get us a current. If we have a current, we can do stuff with that current. Okay, great. Party tricks. Who cares? Well, we pretty much generate all of our electricity that way. We just need to get a magnet turning or a coil of wire turning in a magnetic field relative to each other, and we can generate electricity. Now, it kind of flips back and forth because north and south are flipping back and forth, so we get alternating current, but we have clever ways of managing that and basically alternating it so quickly that we just don't even notice that it's going back and forth. Okay, great. So we're generating electricity right now. There's just a little bit of waterfall, kind of simulating what a hydroelectric plant would be. You have falling water. There's potential energy there. Spinning a magnet or spinning a coil around a magnet generates electricity. When we burn fossil fuels, coal, oil, gas, we are burning the fuel, which is heating water, which is turning to steam, which we put through a little turbine, and guess what? Spins a coil or a magnet, generating electricity. Nuclear power. Again, we're using nuclear reactions and uranium to heat water, boil it, turn it to steam, send it through a fan, and again, get a coil of wire or a magnet spinning. All of this is basically to get a coil of wire or a magnet spinning, and we can generate electricity and start doing clever things with it. Okay, great. So what else can we do with that, Mr. J? Well, that's not all. When we start looking at motors and generators, if we have, let's say, wind power, there's a little fan on the front of this, spinning the coil in a magnetic field, the light bulb lights up. All right, so that's a generator, but it's really just a motor run backwards. If we do it the other way, same setup, and we stick a battery where the light bulb was, that battery is going to give us a current, and the current's going to be in a magnetic field, and when you have a current in a magnetic field, that's going to put a force on those charges, and that's going to spin. So basically, a generator and a motor is the same device, just run in 2 different directions. Ha! All right, there's like a week and a half of actual class right in those 2 slides. Moving right along. What else can you do with electromagnetism and coils and wires and magnets and stuff, Mr. J? Well, you were hearing me in the first place because of that very phenomena. So over here in the GIF we have, yes, I say GIF, not GIF, get over it. We have a speaker. Well, it's a cutaway of a speaker. So we're sending a current through a coil of wire. That coil of wire is around a permanent magnet. So when we send the current in, that's generating a magnetic field, which opposes the other magnetic field from the permanent magnet and pushes the coil forward. Then maybe we switch the current and it pulls the coil and pulls the cone back and forward and back. And now we're creating sound waves. Now that's the reason you can hear my voice. But that's how we're creating the sound. But guess what? How I'm recording it works exactly the same way, just backwards. So instead of generating the current, which moves the speaker, I'm generating the sound waves, which moves the cone of the little microphone, the teeny little microphone that's in in the laptop right now, which moves a coil of wire around a permanent magnet, which generates a current, which then goes through some other stuff. And again, we encode that to transfer to other places. So speakers, motors, generators, same device, run different directions. Speakers, microphones, same device, run in different directions. Okay, great. It's all about moving electrons. What can we do with those moving electrons? Well, pretty interesting things. Let's say I had a really, really big antenna, but basically it's just a thing that has a lot of electrons in it, right? And I want to wiggle that electron a little bit. Well, that sends a little disturbance. What I'm changing here is the electric field. We're looking at the electric field as that moves. If I change it pretty drastically, I get pretty drastic changes in that electric field, right? And that ripples throughout so that the electrons in some other little antenna over here also wiggle. Again, because an electric field, the whole idea of fields is that that's what's putting force on one electron to another. You're changing the electric field around in the space around you. So if we can change that in very clever ways, let's say oscillate this at a specific frequency, at a certain amount of times per second, then I'm going to change the electric field by that much. Now when I do that, I'm going to flip back to my other GIF over here. When I change the electric field, right, when I was sending a current through those wires, that generates a magnetic field. That's the red one here. But when I generate a changing magnetic field, that generates an electric field, which generates a magnetic field, which generates a electric field, which generates a magnetic field, which generates what you see where I'm going with this, right? You have this consistent propagation of this disturbance in the electromagnetic field. The electric field and the magnetic field aren't actually two separate things. They're the same thing. They're two sides of the same coin. And this blew people's minds come like end of the 1700s-ish, early 1800s, when they started wrapping their heads around, hey, when we do these electrical experiments, when we turn it on and turn it off, we get that spike of current as we turn on and turn off, our little thing that's measuring magnetic field changes. That's weird. It's because this right here. As we change the electric field, we get a changing magnetic field. And that disturbance propagates. We have an electromagnetic wave. All right, back to my antenna. What can we do with that wave? Well, I am speaking into a microphone right now. So that's sound waves into a shaking little magnet, into an oscillating current in my computer screen, which basically has an antenna in it, which wiggles some electrons back and forth, which sends an electromagnetic wave to my router, which is across the room, which has another antenna. That's the little guy over here, which because of that changing electric field, it starts wiggling some electrons, which starts wiggling some electrons in the Ethernet cable that it's connected to, which goes to the service provider, which goes to some other cables, which finds its way to Medway, which finds its way to your house, which goes to your router and wiggles some electrons and sends some electromagnetic waves through your household to your device that you're sitting in front of right now, which shakes the speaker coil on your computer, which you hear my voice. It's the same oscillation, and that blows my mind. And typically I spend a week in class like doing all these examples, doing it, but I'm cramming it into like 4 minutes, 5 minutes, 10 minutes. I'll keep going on. Anyways, we have wiggling electrons that change an electromagnetic field that spreads out as a wave, an electromagnetic wave, to wiggle some other electrons somewhere else. That's the idea, and I personally think that's awesome. So for activity 2 this week and going into next week, we're going to look a little more at, okay, we're wiggling electromagnetic waves, but how can we measure these? What about them? How fast are you wiggling them? How much are you wiggling them? What's the time it takes between that? What's the distance between these peaks going across here? There's lots of things that you can measure about these waves, and those differences are very, very important in terms of, well, is it going to talk to my cell phone, or is it going to make me feel warm, or is it going to actually do things to my eyes that I can actually see it, or actually burn my skin, or actually like go through me and see my bones? You see where I'm going with this. There's a whole lot of different types of electromagnetic waves, but the only difference between radio waves, let me make this bigger again. The only difference between radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, all of these different types. It's all light. It's all just electromagnetic waves at different frequencies, some going faster, some going slower. It's all the same thing. I know. Okay. There's 2 videos for activity 2. And then another form that's like a 3, 2, 1, 3 things you took from the video, 2 questions this kind of brings up in your mind. And I forgot the one thing was offhand, but it's in there. You'll see it. So that's what you're doing for this week. Sorry we couldn't do this live, but I will see you on Monday. If you have any questions, shoot me an email. Thanks. Bye-bye.